hopefully. So I'm going to import pandas first. And what I would like to do is import the production data from both. So let me just go to the path. Just a second. Where is the data? So here I have a production data from both. As you can see, it's an Excel file. And what I would like to do is bring it into a production data frame using pandas. So within the pandas function, we can access things like read Excel, as you can see here. And in read Excel, the only thing that I need to provide is a file name. If I have multiple sheets, I can provide also the sheet name. But for the time being, that's all we need. And let's have a look at this data. Let's see if the data has been loaded. So the data has been loaded. So it's it has a date column, some wellbore code, and some additional codes for the well name. If there is any question and I cannot answer because it's sometimes I need the multiple screens, just let me know. What does the R? Oh, Mike, why does the R before the path in the indices? Okay, that is just to tell Python that all the string that I'm specifying here needs to be read as row strings, because these slashes usually mean something. It's like when you set tabs, or when you make you create a new line. Usually you indicate, you use this type of use a backslash to indicate the special characters. So in order to avoid Python to interpret these as backslashes as special characters, we use R. The other thing that you will find is that some people use double slashes. Okay, that's the reason. So we've got the data read into Python, into the data frame, and I would like to explore a bit more of a data. So one thing that I would like to do is I'm going to get just all the columns first. So I can do df prod columns, and I can see all the columns that I have in here. So including downhole temperature, downhole pressure, how many hours on a stream has been a well on a given day. Of course, the well name, as we show. I guess this is the choke. How much is the percentage of open? How open is the choke? Wellhead pressures and wellhead temperatures. And let's get the name of the wells. I'm going to store here the well names. And from this, from the MP wellbore name. So from this one, I'm going to get the wellbore names, and I can use a unique function to bring only the unique values of the wells. Let's say without repeating the names. So I have 1, 2, 3, 4, 5, 6, 7 wells in the set, right? And if I would like to do a bit more of understanding of the data, just before I load it into the database, And let's describe here the data and see what's happening with the data. We can see how many values we have in total for some of the codes. And it's possible to see that there are some missing values. As you see that there are 15,000. In fact, if I do df rot.shape, we can see that there are 15,634 rows. And there are cases where I'm missing the data. So let's see if the information makes sense. For instance, downhole pressure, we see the minimum value is 0 and the maximum value is 387. So it means that this is in metric units. And so much more information about it. I'm not going to go into the details, but here you have a bit of a exploratory ranges of values, which will help us to indicate whether we have null values or whether we have to replace some of those null values in the data, right? So I'm going to carry on. And the next thing that I would like to do is I'm going to keep some of those columns, not all of them. So for that, I'm going to keep, let me take note of the columns that I would like to keep. Of course, the well name, for sure. It's something that I would like to keep. I would like to keep the well name, downhole pressure, why not the downhole temperature, well, let's go to the oil volume, the water volume, and the gas volume, and the water injection. And I think it would be also good to have the wellhead pressure, as we may use it later on. I think I have the average downhole pressure, and I may need also the wellhead pressure. What else? Downhole temperature. Let's say average wellhead pressure, and probably the average wellhead pressure. I have it. Downhole pressure. I have it. Should be fine. Okay, so if I do that, I can see that now my table has been just cut down to a much shorter version of the table that I showed you before. And but I want to change the column names because I want to have something clearer on my database. So this is my proposed names for the well name. I just want header well. For the I need the dates for sure. There is yeah, exactly. So I need the dates, which is I can oops. Let me go back. Yeah, no, well, the elapsed time will get from the dates as well, so that's fine. And from the data from all these, the other thing that I would like to do is compare the average wellhead pressure, and let's call it EHP. And what else do we have here? And the downhole temperature. Just for fun, why not? Let's call it buttonhole temperature. So I have this dictionary, and I want to use this dictionary to rename all these columns. I think I'm missing. I have a water injection as well here. Okay, I have everything. In order to rename the columns with this dictionary, I can use the fprod.rename, and I can pass with the columns argument the name of a dictionary. In this case, it's called column names. And let me do that replacement in place. So if I do the fprod now, and let me do just the header. So I have now something quite neat. Dates, well, doing a pressure, bottom of pressure, temperature, and the volume quantities that are actually daily amount of production or injection per well. And as you can see, this is a smaller table, same amount of rows, but only nine columns. Just going to make a quick plot. Let's use Seaborn. To make a quick plot, and I think I can do SNS.line plot, and I'm going to use a dfprod, and I want to put here the dates, and I want to put the dates, and I want to put here the oil volume. And I could, if I do that, I can also use a hue to indicate that I want to color by the wells. So I can put here the well. Let's see if that works. Yeah, so quick plot. We can see which the F12 is probably the highest producer along the F14, and then we have some other wells that follow along, like the third one will be the F15, and some wells produce or drill after 2014 without not so much success. Probably the F11 had a bit of an intervention at some point, something interesting to see on the data. Right, so let's do what we want to do, which is, or the original, the point of what we're doing here, it's push data into a SQL database. I'm going to create a new database first. For that, there is the flavor of database, of SQL database that I'm going to use is Postgres. PostgreSQL, it's an open source database. It's quite popular if you have a look at the number of companies and the usage of PostgreSQL. It's quite high among the databases. Of course, you have other flavor like MSQL or MS-SQL or MySQL and so on. So, but I'm going to use PostgreSQL, which is, as I mentioned, open source. And I have my database server here, and I have quite a few databases here. So let me create a new one. And I'm going to call it Wolf_PEG. So it's creating the database. And a PG admin, this is a probably I have skipped this a bit, but PG admin, it's a way to create create databases, delete databases, create tables. It's an administrator or using interface to create, edit, and also have some sort of control of add privileges and authentication to the database. So you can download pgadmin from their website, and this is another open source tool as well. So it's all is in here. So it's the latest version, but you can go into the downloads, and they have different versions from Mac OS up to Windows. Also, you can run in a container if you are in that world. But here I have, I'm going to go into my Vault PEG database. And at the moment, if I go into databases, there are quite a few things here, but if I go to the tables, there is no table added here. So what I would like to do, and let me close all this stuff. Don't save. Let me close all this stuff to avoid confusion. It's to push some data here, and the data that I'm going to push is first I'm going to push a well metadata where I have the well name with the latitude and the longitude, and then I'll push some of the production data. So I'm going to use two ways to push data. So, but first, let's create the connection to my database. Okay. For the connections, I have here, I have my credentials that I'm just going to copy, put in here. The credentials is nothing but just a file with my username and my password to show it around. So I can come here and import that file. So I'm importing my credentials. So I can say user equals to credentials dot user. My password is equals to credentials dot password, and that's it. I'm not going to show you what is in there. But what we would like to do, it's also, I would like to specify the database name, which in this case, as I mentioned before, it's Vault _ PEG. And I also need to create a string which represents how I'm going to connect to a database. So just to, I'm going to put here SQL flavor. And this is just a representation, so I can tell what is the database that I'm going to connect to, and what is the driver that I'm going to use. Okay. Now, so all this specification that I have here, it's just variables that will be consumed by a library. So if I show you, if I put here an image, so we have different components here. We have obviously the database. In this case, as I mentioned, I'm using Postgres SQL. And I have also a administrator component, which is probably at the top, which is pgadmin. I also would like to interact with Python somehow. So Python/Jupyter. And the way I'm going to interact with Python and Jupyter is through let's put it here, this library in Python that is called SQL Alchemy. So SQL Alchemy, it's a quite powerful library that not only has the potential to establish connections to a database and push and retrieve data from the database, but it also often offers an object relationship mapper to the database, which is a bit of an advanced option. We're not going to use it here, but it's quite useful to control how how your database grows through Python. So for the time being, we're not going to use the object relationship mapper in the database. No, Maria, we are just creating the database now. I created the database using pgadmin, as I showed just before. But the database at the moment, so there is a question if the database, it's the one that I created here. I use pgadmin to create a database, but it's empty. So there is no table here. So we are going to put tables. We're going to put the tables in the database from Python. And the point of this is that pgadmin can do some of the edits and some of the same, let's say, functionalities that SQL Alchemy can do, but in a more through a user interface. Okay, you can do queries, and I'll show you a bit as we go along. But of course, we are in this world, in the world of Python, and we're going to use SQL Alchemy to connect to the database. I hope that was clear. And so let's import SQL Alchemy. And the way that you will find it around is when you import SQL Alchemy, you import it as DB. Of course, you can put whatever name, whatever name you want. And so now I have here some variables, like my database name, the flavor. As I mentioned, we're going to use PostgreSQL, and this is pretty much a driver. It's almost like a low-level, very low-level functionality that allows to also communicate to the database. But SQL Alchemy is sitting on top of Psychopg. I'm not quite sure how is it pronounced. So the engine, I'm going to build an engine string to connect. In that engine string, I need to pass the SQL flavor. Yeah, SQL flavor. And I need to pass the user. I need to put a column here. I need to pass a password. And I need to tell where the database it's connected. In this case, it's in my local host. So you can have a database anywhere in the cloud. And I think you can put at localhost, and you can put also the port here. Let me try with the port. I didn't try before. And also you need to specify what is the database name that you're trying to connect. So I need to put the DB name. Okay, let's see that works. So that is just variables. And now this is where I'm connecting really, where I'm using for the first time SQL Alchemy. So I'm going to define my engine as DB, which is calling SQL Alchemy, create engine, and I'm going to pass this engine string that I built before. See, okay, nothing. And so that's just the engine, and I can also, I need to specify for later on for certain users, the connection. So I need to use this engine and connect. So when I execute SQL queries, I can use this, I have to use this connection. Okay, so far we haven't really done anything on the database. As you can see, if I refresh this, there is no table, nothing is happening there. And I'm just establishing a connection to that database. But let's create our first table. No? So let's do here, create a well meta data table. And this is where I want to put things like the status, probably not the status of a well, but the well name, the API code of a well. I may want to put the top latitude and longitude. I may want to put the bottom or certain information, latitude and longitude, as a bottom reference, and any other information that at least if you are in the United States, or if you are in the North Sea, like this case is which sector or block of the North Sea this well belongs to. So it's just one common data or some certain data that give some information about the well. And in our case, from DB, from the SQL Alchemy, I have to define some sort of meta. And actually, let me put it in here. So the meta information, it's db.meta. This is our metadata. It is almost like a just configuration of a database. Now, if I want to create a table, let's call this a well meta, the table, and there are quite a few functionalities that I can use from SQL Alchemy. Let's import some of those. So from SQL Alchemy, import table, and let's see what else we can import. We can import some of these columns, quite a few things that we can import here. So for the time being that we are going to use a table column, we're going to use strings because we have to pass the name of the wells. And of course, we have to use also an integer to give an ID to the well, and a float to give the coordinates, at least the latitude and the longitude of a well. So now going back to the creation of a well data, I'm going to use this table, and I have to put a name to that table, which in this case, I'll call it again, well meta. This is a name that we'll have in the database. And I'm going to use this. I'm going to create my columns. So the first column is going to be the ID, and it's going to be an integer. And it's going to be kind of my primary key in here. So this is primary key is true. And the next column will be my well name. Let's call it well. And this is going to be a string. The next one, I'm just going to do a couple more. Column latitude. Let's put it lowercase. Latitude. And this is going to be a float. And the last one, it's going to be longitude. And this is going to be another float. Okay. And that's all fine. And then I can call the meta and I can say create. Let's go to the functions that we have in meta, create all. So I'm going to create this. Run it. Oops. Oh, sorry. There's a comma here. I need to pass ending here. The well meta is already finished for this meta instance. Specify existing. Let's see if something happens here. No, nothing has happened here. Okay, don't know what happened there. Okay, let's refresh here. And if I refresh, I have now the well meta here. And if I explore the columns, what I have in there, pretty much I have nothing. So if I execute this query, I have this ID, well, latitude, longitude. So that's perfect. I have an empty table, and what I'm going to do is populate that table. So something that I know the latitude. So first of all, I know the well names. And you have to trust me here that I have calculated already the latitude of the wells, that I'm not going to bother you with that piece of work, but I know that the latitude of those wells are these values. So it's just an array for every one of those wells. I have a latitude and a longitude. Okay. And the longitude of the wells, and let me copy this, are these values. So I have my lat long, and now for the last bit, what I'm going to do is iterate on every one of those values and push that data into the database. So for every, let's say for every well in well names, I'm just gonna enumerate this. For every well in well names, what I would like is to insert some data into a database. So I'm going to take the well meta table, the well meta, and I want in the well meta table, I want to insert some values. And the way I can do it is the values that I want to insert are the ID. So let's remember that I want to insert ID, well, latitude, and longitude. So ID is equal to just one integer that cannot be repeated. Then I have the well, which is a well name. Then I have a latitude, which is the lat, and I'm iterating on every one of these latitudes. So the lat the lat I, and I have the longitude, which is equal to the long I. And so I want to insert this, and this is just a statement that I need to use the connection and execute the connection. Okay, so if I run that and I refresh this, now I can see in my database all that information. So the well name, the latitude, the longitude. And that was a bit of a long way around to generate that. And imagine if I have to do the same for the whole production data. So which have a lot of, let's say a lot of rows. I don't want to do that for the production data. So let's use, I'm going to show you, let's say, populate the DB using pandas functions. But this is probably a shorter way to do the same thing. We could have created a pandas data frame and populated. So the way I'm going to do it's now I'm going to populate the production data that we have before. So remember that we created this production data. Yeah. And what I would like to do with that production data is do, I can do to SQL. And I can put the name of the production table that I want to use. Let's call it production. And I can use, I have to specify the engine, which we have already done. So this, we still have to do all these steps here above. But I wouldn't have to create a table. I don't have to do this iteration. I just have to set the name of the table that I want to create, set the connection, and straight away send the data frame. So if I do that, yeah, it's running. Python seems to be running. It's probably doing exactly the same that I was doing here on the background. So let's see here, let's refresh. And now I have a production data. So if I query the production data, in fact, let me show you a bit of a query. So I can use the query tool. And right here, I want to select all the columns from production. Okay, so now I have all the columns from production. I have a dates, well, THP, VHP. So nice thing about this is that I can now use, I can query the database, which is what we're going to do next. So up to this point, is there any questions before I move to the next exercise?
Alejandro, can you hear me?
Sure, yes.
So can you do the same for the latitude and longitude using the pandas function rather than to do all this long iteration that you did before?
Yeah, yes, yes. Yeah, okay. Yeah. I could have created a pandas.
Okay.
And but I think it's important for you to understand what's happening on the background because you need to. Okay. You probably need to do this at some point.
Okay.
Yeah. No, with to SQL, no. Actually, that's a good point. You don't have to specify types. The types, if you see here on this on pgadmin, you can see that dates have been already identified as timestamp. Well is a text, so this is floats or precision floats. So it's pretty much a one-to-one conversion to whatever you have in pandas. So if I see, for instance, I think .info. Is it .info? I don't want to do this. Yeah. So if you check the type of data that you have, I thought it was .info. If you check the type of data that you have for instance for dfprod, let's say dfprod for the dates. Okay, so this is a timestamp, and that's what it's that's why you have already there in the database as a date. So was the date on datetime 64 format already? No, the date is we read it from the Excel, and the pandas interpreted it as a timestamp. Oh yes, thank you, John. Yes, so I need to use .info. Yeah, that's what I was looking for. Yeah, dates. It's as you can see, it's a date time already interpreted as when I loaded the data from the Excel. And I guess when you push the data to the database, there is already a mirror of a type of object that you have in pandas and the type of object that you have to push into the database. Okay.